Alright, in Chapter 5 we're going to talk about systems of equations and inequalities. And what we're going to try to do in this first section, section 1, is we're going to solve linear systems. So your example will be something like this. It'll say 2x plus y equals 1, 3x plus 4y equals 14. Now there's a couple different ways or methods you can use to solve this. One of them is, or the first one I'm going to show you guys, is the substitution method. Now substitution just means that you are going to be replacing part of it for or part of the equation with something, and then trying to solve for one of the variables. So the first thing that you want to do is solve for one variable. And what we mean by this is that you're going to take one of the equations and you're going to solve for one of the letters. So for instance, in this particular problem, I'm going to solve for that one right there. So that would be me taking the 2x and moving it over to the other side. So I'd have y equals 1 minus 2x. Step 2 is you're going to substitute. Now what they want you to do for this is they want you to put this right here in for the y in the other equation. So it's going to look like this. 3x plus 4. Now I'm going to take the y out and put 1 minus 2x, because that's what we solved for, equals 14. And now from here you got to solve for whatever variables is left over. So you're going to distribute here. So 3x plus 4 minus 8x equals 14. Combine like terms. Very careful that they are on the same side, so you're just going to combine like terms. You're not adding the 8 over or anything like that. Don't get into that rut there. Subtract 4 to both sides. You get negative 5x equals 10. Divide by negative 5 to everything, and x equals negative 2. So once you get that one, then we're going to do what we call back substitute. And what they mean by this, by back substitute, is you're going to put this answer back in and see what the y is. So it's y equals 1 minus 2 times negative 2, because you got negative 2 to be your x, so you replace it back in there. Negative 2 times negative 2 is 4. And I end up with y equals, oops, I already wrote the y equals. And it equals 5. So as an ordered pair format, that'd be negative 2, 5. Meaning that when you would look at their graphs or look at their things, those two lines are going to have the same answer when the ordered pair is at negative 2 and 5. So that's one of the methods that we can use as substitution, where you want to solve for one of the letters, substitute it, and then find one of the variables, and then replace it and find the other variable. The second method that we have is elimination method. Now elimination method has, again, a couple steps. First one is going to be adjust the coefficients. And remember what a coefficient is. Coefficient is just the number in front of it. What you want to do with this basically is you're trying to make sure are everything lined up with the x's on top of the x's, y's on top of the y's, and so on. And then as far as adjusting it, it means that you might have to use some multiplication in order to, if you were to add straight down, you want one of the letters to go away, if that's possible. And if it's not, use multiplication to both the equations or one of the equations in order to make that happen. Second thing that you're going to do is you're actually going to add the equations. So what should happen, as long as you adjusted correctly, you'll have just an x left or just a y left, and then you just have to solve for whatever that letter is. And then the third step, just like on substitution method, you're going to back substitute, which just means plug the answer back in and see what the other letter is. So just to keep it kind of similar, I'm going to use the same exact formula. And the reason why I'm doing that is I want to show you that it doesn't really matter which technique you're going to use or which method you'd like to use, but it's going to be the same in the end. So as far as their first step goes, by adjusting the coefficients, if I look at adding straight down right now, I would have 5x and plus 5y, and that's not what I want. I want to have it so that one of those go away. Whether you choose the x or the y, it is your choice. My choice is I'm going to choose the y, so I need to multiply this equation by negative 4. Now the reason why I'm doing that, and all I'm doing is distributing the negative 4 out, is so that when I add them straight down, my y's will go away. Okay, and so when I go straight down now, I get negative 5x equals 10. And if you recall from the previous way I did it with the substitution, this actually is the same as what the substitution was. X equals negative 2. Then in order to get the other one, or to get the other answer, if I replace negative 2 back in for x, I get a negative 4 plus y equals 1. Add 4 to both sides. I get y equals 5. So again, it doesn't really matter whichever method you want to use. You're going to get the same answer. So that's kind of the reason why I did the same exact problem, just so that way you guys could see that it doesn't really matter. A third method that you guys have already learned in section 1.9 of this book, and that is the graphing method. And for graphing, first step that you'd want to do is solve both equations for y. Step 2, graph both and identify where they intersect. Now, if you're using a TI, for instance, like a TI 84 or 83, your calculator will actually give you all that information if you ask it. Once you plug them both in, like one into y1, one into y2, then you go second trace, and it's option number 5, where you just have to tell it which is equation 1, which is equation 2, and then see what you get. So just so that I stay consistent with this, if I have 2x plus y equals 1, 3x plus 4y equals 14, and it's the same problem. Subtracting 2x again, I get y equals negative 2x plus 1, so that's in slope-intercept form. If I subtract 3x, and then divide by 4, I get negative 3/4 x, and then 14 over 4 is going to reduce down to 7/2, or 3.5, or 3.5, or whatever way you want to plug it in. Then graphing that, see, here's the problem with graphing. If I'm not going to use a graphing calculator, how do you graph those fractions? They get to be kind of tough. Okay, so this first one said up 1, and then it's down 2 over 1. So I get a line that comes in here, something like this. That was that first one, of the top one. I'll graph the other one in blue so we can kind of see it. Then up 7/2, which is 3.5. So 1, 2, 3.5 is about here. And then down 1, 2, 3, and over 1, 2, 3, 4. Okay, I end up with something that looks like this. Now, here's the bad part with graphing. Without using a graphing calculator and without using grid paper, is how do you know when and where this actually goes? So since we know that the answer is negative 2, 5, that's the ordered pair that it hits at. When you use a graphing calculator, you're going to be a lot more accurate, just because of the fact that it actually gives you the coordinates. Or even if I would have had used graph paper, you would have been able to see it a little bit easier. So just so that you know, Either one of those methods are perfectly fine to have or use. It shouldn't matter whichever method you want to use. It's up to you. Whichever one you feel comfortable with, they all solve the same way. The only other thing that might happen and might show up for you is when you're using substitution or using elimination or graphing for that matter, there's going to be times where the graphs actually don't cross. So for that particular situation, if your graphs don't cross, or if all the letters cancel and it ends up being like 0 equals 8, that's a no solution situation, or in the graphing sense, they would be parallel lines. Parallel lines are never going to touch, so they're not going to ever intersect. They're not going to have that common point. There's other times where the lines might look differently, but realistically they are the exact same line. So where they cross all the time. As an example for you, if I gave you something like this, 3x minus 6y equals 12, 4x minus 8y equals 16. Okay, so first of all, if I'm going to use elimination, for instance, then if I get rid of the x's, I'm going to multiply this by -4 and this by +3 and see what happens. I get negative 12x plus 24y minus 48 plus 12x minus 24y equals +48, and when you add them, it gives you 0 equals 0. Now in my classroom, that to me is the equivalent of all real numbers, because what's happening is when you graph them, they're overlapping each other. So where are they touching? All the time. So all real numbers is something that I will accept. However, if you look at another type, what they usually or typically do is they typically write it in slope-intercept form, where if you were to take, let's just take the 3x minus 6y equals 12 and solve for y. So if you subtract 3x and add 12, and then, or not add 12, just plus 12, then divide everything by -6, you get 1/2 x minus 2. Okay. They usually let a different letter, like the letter t. They're saying if x is t, then y is going to equal 1/2 t minus 2. And all they're doing here, you guys, is they're just taking the basic equation, or the equation that both of these two reduce down to, and setting it into like an ordered pair situation. So realistically, it isn't going to much matter. Like I said, for me, I usually use an R, like an all real number situation, because they connect, or they touch all the time. So, or you can have it in terms of an ordered pair format like that. So, anyway, that's section 1.